Here we have a domain and range application problem. It's kind of interesting, a simple problem, but very interesting. Consider the function f of x equals to x and g of x equals to x squared. Determine domain where f of x is greater than g of x. Okay, so to understand it, let's try to sketch it first. So what is f of x equals to? F of x equals to a straight line x, right? So let's draw this. Let's say this is our f of x. Correct. Now what is g of x? G of x is a parabola, x squared. So it's a basic parent function. So let's draw this basic parent function. So this is our g of x, okay? And the question is, where is f of x greater than g of x? So can you find from the graph? Okay, so you see from 0 to this point, the red line f of x is over the blue line. So this probably is the solution set. Do you agree with me? So that's your solution set. Is it okay? So what we need to find here is what are the common points between f of x and g of x. And if you know that, then we can solve it. So we say, well, to find this, let us first try to find where is f of x equal to g of x, right? So we say, well, let's solve it. So it's x equals to x squared, right? Okay. Now to solve this, what we can do is we can take x on that side and say we have x squared minus x, and then I'll factor out x from here and write x minus 1, correct? This gives me two solutions. The two solutions are that x equals to 0 or x equals to 1, correct? So I get this point as 0 and this point as 1. Now the problem is, where is f of x greater than g of x, correct? So it is greater than g of x only between these two values, right? Therefore the solution is f of x is greater than g of x when x is greater than 0 but less than 1. Do you get it? That is how we need to solve this problem. But let me highlight few things where things could go wrong. One is at this place itself. See how I brought x on one side and then factored it out? I have seen students doing like cancelling x, right? In that case they'll have sometimes they even write 0 equals to x and then they get lost and they don't know how to get this point. Well, if sometimes they cancel it correctly and they write 1 equals to x, then they get only 1. They don't get 0 point, right? But since they know that these are the points where the things are equal, they do get the answer. But so many times I've seen a mistake in these few steps. I would like you to make a note of these steps and follow them like this, so that's absolutely clear as to what you're trying to get or achieve, right? So once you do that, you can explain, well, between this region, f of x is greater than g of x, and therefore the solution is this, correct? That's how it is. Or if you don't make a diagram like this, then we can solve it as an inequality also, correct? Let me show you a part of it here, which you can do yourself. When we say f of x is greater than g of x, then f of x is x. So we say x is greater than x squared, right? Now we can solve this inequality, correct? And so we bring it. We say x. We can bring it on one side, either this or there, doesn't really matter. Let's bring it on this side. So we say x minus x squared is greater than 0, and we can take x common and we say 1 minus x is greater than 0, correct? And now we can make table of values, and let me show you that. So we can make table of values here and then check. So we have zeros here at x equals to 0 and x equals to 1. So x equals to 0, we have 0 here, and at 1 we have here. So you can take a test point on either side. So let us say that our test point is on this side, let's say test point is -1, and between them, let's say the test point is 0.5, and after that let it be 2, right? So if I plug in -1 here, then 1 minus -1 make it positive, but -1 here will make it negative, right? So we really get a negative value here. If you plug in 0.5 here, then 0.5 is positive, and 1 minus 0.5 is also positive, and positive times positive will give you a positive value. Is it okay? If you plug in 2 here, then this is positive, but 1 minus 2 will give you negative, and you get a negative here. Since you need x into x, 1 minus x greater than 0, that means you are looking for something which is positive, correct? Therefore, this is your answer between 0 and 1. I hope you understand this method of inequality also. So here, if you see at the sheet, I have given you 3 different ways of solving the problem. So the first way here before us is the graphical solution. So we call this using graph, right? And this is algebraic solution. This is also an algebraic solution using table of values, correct? So here we have used table of values to find out the solution, correct? So these are different ways of solving this problem, and any one of them can be used to solve similar problems. I hope the understanding helps you long way. All the best, and if there are problems, you can put your comments and I'll be answering them soon. Thanks.